I'm going to use Google Maps to illustrate several key points about the way that you can take a traditional use case and move it towards personalization. Take this map, for example. Every morning, I glance at my phone and it tells me the way to get to work. There are 3 possible routes, and today, the highlighted route is the fastest. Sometimes I go to Google Seattle, crossing the floating bridge across Lake Washington, and Maps tells me helpfully that the bridge is closed. Is this machine learning? You could think of this as being just a set of rules. Google has to collect a lot of data to make this use case possible. Where the roads are, for one, the traffic on each road, bridge closures. But the algorithm itself? Routing algorithms between A and B subject to a set of constraints. That algorithm is called the A-star algorithm. And the A-star algorithm is taught in undergraduate computer science classes. And it works by considering all possible routes between points and focusing on shorter ones. It's not that complex once you have the data. So you can do this for entire countries at a time. Get data on the road network and provide routing directions. Traffic and bridge closures are a little more difficult because you have to work with many smaller government entities, but it is still not such a huge data problem. The logic, once you have the data, seems quite tractable. Now take the case in the middle. It's still Google Maps. I was in Japan, traveling from my hotel to the Google office. I was in a subway station called Roppongi, and Maps told me that I was on floor number 2. How did Maps know? Whatever the data sources it uses, Wi-Fi points, barometric pressure, typical walking speed, it's pretty obvious this cannot be a simple set of rules. Plus, of course, you need the relevant data to train the model and the relevant data to keep the model remaining fresh. And once you have the data, you can now use machine learning to avoid having to write the logic. Maps here is anticipating information that you might want to know if you are in a multi-story building. What else can Maps anticipate? Look at the map on the right. Still in Japan, I glanced at my phone between meetings and noticed that I was getting a recommendation. Maps is now connecting my history, that I like art, that I like museums, that I'm in Japan, to now recommend things to me. This is even more of a data problem. The machine learning is what allows the original limited how to get from point A to point B map to now become a virtual assistant. Personalization of the map service is possible only with machine learning. So machine learning is about scaling beyond handwritten rules. But then you start being able to do things that you could never achieve if you were handwriting rules. So think about your business. Your business analysts today are essentially looking only at the bulk of your business, the 80% of things that 20% do. That's akin to the use case on the left, the stuff that everybody in the country needs, one set of rules for everyone. You might be thinking of machine learning as a way to do the things in the middle, of being able to take the data you happen to have and training a machine learning model. But think of machine learning as a way to get to the things on the right, of being able to personalize your services for each of your customers. And notice a question at the bottom of the card on the right, asking for user feedback to keep improving the model. That too is very important.